We first want to talk about the motivation of why we are studying binary search trees, and then discuss what binary search trees are. In the last lectures, we stated that we would like to build efficient sets and dictionaries because we could solve numerous problems with dictionaries. And if you really develop some practical applications or your own programs, then you are going to use dictionaries quite a lot. So that's why we are interested in building efficient sets and dictionaries. And we set a goal to make these operations O log n. So in the last class, we discussed how we can make find, insert, delete, find min, and find max operations O log n. And we use tree-like data structures. By the way, what is a binary search tree? A binary search tree is a special type of binary tree, and the value in each node must be greater than or equal to any value stored in its left subtree. And the value in each node must be less than or equal to any value stored in its right subtree. So what do these two statements mean? I'll show you a picture. So when you see this one example of binary search tree, let's have a look at this node. This node has the value 5, and this value is greater than any values stored in its left side. So 1, 2, 3, 4 are smaller than 5. On the other hand, this value is smaller than any values on its right side. So 6 and 7 are greater than 5. And these two properties are satisfied for all the nodes. So when you have a look at this node, 2 is larger than 1, which is on its left side. However, 2 is smaller than 3 and 4, which are on its right side. So these two properties should be satisfied for all nodes. So this is what a binary search tree looks like. And there are some features of binary search trees. Like a normal binary tree, we can traverse a BST. BST is an abbreviation of binary search trees. And you can do pre-order, in-order, or post-order traversals. However, it is noteworthy, you need to keep this in mind, that in-order traversal in BST will be in ascending order. So if you have a look at this binary tree, when we perform in-order traversal, that is going to be, we're going to wrap this tree in this way. And when we are passing the bottom side of this node, we're going to write down the value of that node. So when we travel this node in order manner, then we do not write down 5 because we are passing the left side. However, when we reach here, we reach the bottom side of 1. So we're going to write down 1, 2, we're passing the left side, so we just pass, and 3, 4, 5, 6, 7. So the in-order traversal results in a ascending order sorted of the values in the nodes. Okay. Therefore, the in-order traversal is the most frequently used traversal method of a BST. Okay, that was the concept of binary search trees. From now on, we are going to implement binary search trees. But before we go on, do you have any questions? Cool. Let's move on. So we are going to implement binary search trees. And after that, we are going to implement a dictionary using binary search trees. So first of all, we're going to implement a binary search tree. Because we need to implement a special type of binary trees, we need to define a node. In the last class, because we dealt with complete binary trees, we just use arrays to implement complete binary trees. However, in binary search trees, as you can see from this figure, this binary search tree cannot sometimes are not incomplete. So we cannot use arrays to implement this structure, but we are going to use linked list style binary trees. So that's why we are implementing a class node. So we're going to use linked list style implementation. Okay, first of all, we need to define the constructor. And because we're going to use this binary search tree or implementing dictionaries, we're going to receive two values. The first thing is key, and the next thing is value. And because this class node, is going to be a binary tree, we need to receive two things, the left subtree and right subtree. So this is how we are going to define the constructor. And we just need to store the past arguments in this way. So this is pretty simple. And the next thing we're going to implement is find method. So when we are given a key, we want to return the node that has the key, the given key. And I'm going to show you an example here. Let's say we have a tree that looks like this. Take some time for me to write down this trees. Sorry for that. Let's say we have a tree that looks like this. And when we want to find, let's say 4 in this binary search tree, then what we are going to do is we first start from the root and the target is 4, let's say. Then if this value is larger than the target value 4, we need to search for the left side. So from here, we go to the left part. And if we compare this value 3 with the target value, target key 4, this one is smaller than the target value 4. So in that case, we're going to go to the right side. Because the nodes are sorted, the search becomes very useful, very efficient, and we're going to implement that. So if the key we want to find matches the key at the current node, then we are going to just return self. However, if key is smaller than the current key, then we are going to go to the left side. And we can just call the find method on the left side like this. However, this is only when we have left part. Otherwise, we are going to just return none because we don't have a key that is matched. Okay. And else we are going to return self right, find the key. Of course, we need to have the right side. Else we are going to return none. So because we have the binary search tree properties, the find method becomes very easy to implement like this. Okay. And another method that we are going to implement is find first. This one corresponds to find smallest. So we want to find the smallest key in this binary search tree. So this is one method that is going to be very useful in the towards the end of this course, this lecture. And a similar method that looks like find first is find last. Using this method, we want to find the largest key in this binary search tree. So this is today's first PPP exercise. Take some time and try to implement these two methods